Hello everyone, my name is Parth. Welcome to our YouTube channel. In this video tutorial, I am along with my friends Harmanpreet and Abhinav will talk about some of the basic concept related to software testing. The purpose of this video is help someone to kickstart their journey to the software testing field even if they are complete beginner. So let's start with the agenda. We are going to talk about the following topics. I'll be starting with testing introduction and life cycle, followed by UML and traceability metrics. And later my friend Abhinav will discuss about various types of software testing. At the end, my friend Herman will introduce you to the awesome unit testing framework in Java called JUnit. So let's start with software testing. So what is software testing? It is basically a process of identifying defects in software so that it can be corrected and eventually improve the software quality. Let's look at the life cycle of the software testing process. Start with the analysis of requirement. Those requirements are converted to UML diagram, and that is going to be a base to the next phase of planning and developing the test cases of our software. We are also using traceability metrics during the test development and execution. I'll talk about in the next slides. Moving on, after the test cases are developed, next phase is environmental setup for the test and then the test execution. That's where the software is being evaluated against its expected behavior through the series of tests. And at the end, there's a closure where we are reporting the bug or defect and closing the test. So this was all about the testing life cycle. Let's see what is UML. It's a unified modeling language. It's a graphical language for visualizing, structuring, documenting the software design on the basis of the customer requirement. So it means the requirement are converted into UML diagram that is very easy to understand representation of the whole software system. The cool thing about UML is that it is independent of any programming language or any platform. All the stakeholders involved in the project activity for the software development or testing, they use this diagram as a reference during any crucial communication. So there are three main diagrams we use in UML. First is use case diagram, another is class diagram, and sequence diagram. So let's look at them one by one. So this the blue picture is use case diagram, typical, which is used to describe a set of actions, which is also known as a use cases, that is performed by some person or a system in collaboration with another person or a system. So they're also referred to as actors, and the actors will have certain goals and scenarios. The other diagram is a class diagram, which is in the green one. Class diagrams are the main building block of any object-oriented modeling. We can show various kind of object in the system, their attributes, their methods, and how they are connected with each other. And the last one is a sequence diagram. It describes how and in what order the objects in the system function. It describes the object involved in scenarios and the sequence of the messages which is exchanged between the objects so that they can perform a certain scenario. So that was a bit of information about UML. Let's move forward and check out what is the traceability matrix. So traceability matrix is a document which consists of a data, preferably in a tabular or matrix form, and the purpose of the traceability matrix is to display the relationship between the requirement and the test cases which are testing those requirements. This table help us to keep track of many things. First thing is we can track the test coverage during the test execution. Also, we can track requirement coverage to make sure there is no requirement left out to be tested. So if any functionality is missing, we can easily identify it. It is also useful to identify the test cases we need to return in order to verify any changes are implemented or any bug is fixed. So typical traceability metrics will look like this. uh, Requirements are on one side of the table, and so these are the requirement IDs, and on the top row it is a test case ID. So and the links between these two are indicated with the cross mark at the respective cells. So that was it from my side. Now in the next part of the video, my friend Abhinav will talk about various kinds of testing. So stay tuned.
Hello everyone, this is Abhinav Bhardwaj, and in this part of the video we are going to talk about how we do software quality assurance. So first off, what is software quality assurance? Software quality assurance is a set of standards that we have to follow to make a good quality software. So to do the software quality assurance, the engineers and technicians, they have to find the bugs in the software, and how they're going to find these bugs, the, that is through the testing activities that we are going to talk about in this video. So let's get into it. Okay, first off, we have to know the types of testing that we do in the software. So there are two types of testing. One is the functional testing and the other one is non-functional testing. In the functional testing, we're going to talk about unit testing, integration testing, system, user acceptance, and in the non-functional part, we're going to talk about performance, stress, and security testing. Okay, let's get started with the functional testing. So functional testing is a type of testing in which the engineers validate the software system against the functional requirements. So here we check if when we give certain inputs to the software, the outputs that we get are expected outputs or not. So we're gonna check the outputs if they are expected or if they are good or not. So the functional testing, consists of four types of testing. One is the unit and the other one is integration. Then comes the system, and the last one is user acceptance. So as we can see in this pyramid, the base of the functional testing is the unit testing. So we're gonna start from the unit testing first. So let's talk about unit testing. So unit testing is a type of software testing where we check the individual components of the system. So we're gonna have a little bit of code, and we're gonna make a function out of it, and then we're gonna put certain inputs in that function to check the outputs if they are expected outputs or not. And we're gonna talk a lot more about the unit testing in the JUnit video, so we're gonna see it in action over there. Okay, next off we have integration testing. So when the unit testing is passed, uh, the different units in the software, they are combined together into the modules, and we perform test cases on those modules then to check if they are good or not. So basically we combine a lot of individual components from the unit testing, and we combine them together and we test them single handedly as a group. So we check if they are communicating with each other correctly or not. So next off we have system testing. So here, as we can see in the integration testing, we check the modules are communicating or not. So here we took all the modules in the system and we grab them as a combined entity and we test them together. So in the system testing, it's kind of both functional and non-functional, because here we not only check the outputs of the system, functionality of the system, we also check the non-functional part, that is performance and stress and security. So we check all the parts of the system, how the system behave as a whole. So in the next part, which is user acceptance testing, it is used to check if the requirements or the specification in the contract are met or not. So we have to check off all the requirements that the customer asks us to make in the software. So in this testing, the customer or the user himself check the software if the functionality is intended functionality or not. So whatever the output we get, is the user is expecting that output or not. So that we do in the user acceptance testing. And now come the non-functional part. So in the non-functional part, we basically check the all the non-functional parts, part of the system, which is the performance of the system, if the system is secure from the hackers and after that we check the reliability of the system, if the system is reliable or not, if it can give the consistent outputs or not. So let's get into the performance testing. So performance testing is basically simply check the speeds and responsiveness of these and the stability in the computer. So here we check if the system has a good performance, if it takes how much memory does it takes in the system, and if it is efficient or not. So it's the basic type of testing that we do in the software. Next come the stress testing. So here we deliberately put the heavy inputs into the system. So we if the system can handle like 100 output at a time, we're gonna put a 150, 200, 300 inputs to the system, and we're gonna check if the system is stable or not. So as it written over here, it involves testing beyond normal operational capacity, often to the breaking point. So we're gonna check how many input does it take to break the system. So to check if the system is reliable or not. Okay, next come the security testing. So security testing, as the name suggests, security testing is where we check if the software is protected against the vulnerabilities, threats, and risk. So here we check the security of the system. In this type of testing, sometimes the white cap hackers, they are paid to crack the security of the system, to check all the vulnerabilities present in the system. So after that, all the functional and non-functional part of the testing is done, and then we can say that our software follows all the SQA steps, and it is good for deployment. And in the next part of the video, we're going to talk about JUnit testing and how we do unit test on the JUnit software. Okay, see you over there.
Hi, this is Harmanpreet Kaur, and I am going to continue with JUnit 5. So let's begin with its introduction first. JUnit 5 is an open source unit testing framework that is used for running and writing test cases for Java. The purpose of JUnit 5 is to adapt Java 8 style coding, because JDK 8 has brought very exciting features, among which lambda expressions is the one. So the JUnit 2 had to be modified in such a way that it can perform testing for all Java applications. Now, as the name says, it is a unit testing, and the basic idea of JUnit is to first testing, then coding. So the approach goes like: we test a little, we code a little, we test a little, we code a little. Every time any new lines of code are added into our application, into our project, we have to re-execute all the test cases to make sure that nothing is broken. Since coding part is done after the testing, so it is implemented by developers in development phase. Now let's see the architecture of JUnit 5. JUnit 5 is basically composed of three major modules, that is Platform, Jupyter, and Vintage. We will discuss each of them one by one. The platform serves as foundation for launching different testing frameworks on JVM. To be able to perform JUnit tests, all the ADIs and plugins, APIs, we have this platform module. The JUnit Jupyter includes new programming and extension models for writing test cases. All the new JUnit annotations, which we will see in coding part, and the test engines, these are involved in this module. The JUnit Vintage, its prime function is to support running JUnit 3 and JUnit 4 test cases on JUnit 5 platform. Now there can be any other third-party module which we can use to support any other programming model. Now let's see some features of JUnit 5. The first one is the test suits. A test suits actually is a bundle of few unit test cases that we combine to run them together. If we want some test cases to be run in a specific order, it can only be done by combining them in one place, and this combination of test cases and running them together is known as test suits. Now, to run multiple test cases, we have two basic annotations that are provided by JUnit 5. That's run with and the suit.suit classes. Next is test fixtures. Now, the purpose of a test fixture is to make sure that there is a well-known and fixed environment in which test cases are run so that the results are executable, repeatable. It is a fixed state of set of objects that we use as a baseline for all the running test cases. Now there are two basic methods for fixtures, that is setup method and teardown method. Setup method actually works like an allocation, like which means that which runs before every test case is called, and the teardown method works like an deallocation which runs after the execution of every test case. Next is test runner. The test runner is used for executing test cases. There is a class provided by JUnit 5 to execute test cases, that is a JUnit core class. And among its various methods, there is one run classes method that is used to run one or several test cases. Now let's see some test classes for JUnit. The first is the assert class. This class provides a set of assertion methods that are useful for writing tests. Only the failed assertions are recorded. Here are some examples of methods of assert class. The first is assert equals, which compares two values, the value that we expect it to be and the value that actually originate. And the second is assert true method that checks the condition if it is true or not. Next is test case class. It defines the fixtures to run multiple test cases. Here is one example of its method, count test cases, which counts the number of test cases that has been executed by the run method. Now there is test result class that collects the result of executed test case. There is a method void and test that is used as an example here, that informs the result class that a test has been completed. Now I think that's enough for the introduction part of JUnit 5. Let's dig into the coding so that we can actually know how JUnit 5. So here we are at the coding part of JUnit. I'm going to create a new Java project and the interface I'm using is IntelliJ. Let's name my project as JUnit testing. Okay, to new window. Here I'm going to create a new Java class. I'm going to name it as cup class. Here I'm declaring two variables. One is for the liquid type string, and another of type double to check the amount. Let's say percentage full. And I'm gonna need a constructor for the same. And I'm going to generate two getter setters for both of them. Okay, now just to create scenarios for my testing, I'm going to modify my code a little. Let's say before setting liquid type, I'm going to check if my liquid type entered by user is not null. If it is null, then I am going to return. And I want a method, a boolean method to check if my cup is empty. If it is, I'm going to return percentage full equals to 0. That means my cup is not is empty. Okay. So now in order to implement testing, JUnit testing, I have to add some dependencies in my project. And to adding dependencies, JUnit libraries is very easy in IntelliJ. You just need to go to the project structure, go to the modules, click on this plus icon here at the bottom, go to libraries to Java libraries, and now go to the folder, to the applications folder where your IntelliJ is actually located. And inside the contents, you have the libraries folder where you need to search for JUnit. JUnit. Here it is, it's 4.12. You have to add that. Besides this, you need to add another library. You'll find that in the same folder, IntelliJ library, and that is Hamcrest. You need to add two dependencies here. Okay, click OK. Now I have to generate the test class for my cup class. Just right click on your cup class, go to generate, and here is a test. It will automatically generate a test class for you. I'm going to name it as, okay, I'm going to keep it as cup test. There is an error, but it says, so we have to add JUnit 5. Okay, I'm going to add it. Yeah, it's gone. Let's make my class public class so that I can run it directly. Now in my cup test, I'm going to create an object of my cup class. Let's say the liquid type is water and the percentage full is 65%. Now I'm going to generate some test scenarios. So to test my code, I have to create the methods under test annotation. The method name is test liquid type. Okay, we're gonna check the type of liquid. As we have seen earlier that there are assert methods in under assert class of JUnit. So we have this assert equals method which actually compares the expected value to the actual value. Let's say I want my expected value to be water and the value I am getting from my cup object is like get liquid type. Let's run it to see what happens. The test has been passed because both the types were equal. Let's say if my expected type was an orange juice. So the test has to fail and it will fail because the actual value it found is water, but it has to be orange juice. Let's fix it to the previous one. And now I'm going to create a scenario where I'm going to test if my cup is empty. For that, we have assert method, assert true and assert false. I'm going to check if my cup object is empty. So basically this condition needs to be, this test needs to be failed because I have 65% water in my cup and it is not empty. See, the test failed is 1 and 1 is passed. This is empty test is failed. If I change it to false, the test will pass. Now let's say I want some lines of codes to be executed before every test and after every test. We have two annotations before and after for that. I'm going to use before annotation. Let's make my method run before. And I'm just going to print a statement here that says I am running before test. Similarly, I want my lines of code to be executed after every test. I'm going to create the method run after that has a statement saying I am running after test. Since we have two test cases, so these two lines of code has to be executed twice, has to be printed twice. Let's run it and see what happens. See, we have the before test and after test, before test and after test for two test cases. Now let's say there is a scenario, there is a case that we do not have some kind of dependencies to test a case, or we have some previous bugs that have not been fixed yet. So we want to ignore that test case. We can use this ignore annotation, and we can also type a message here that previous bugs have not been fixed yet. Oh, my typo. Okay, run it. You can see only one test case has been executed, the other one has been ignored, and it says one passed and one ignored. That sounds good. Now let's say I want to I want to create a test case for null value. I want to check that the user if the user has actually entered some value or is it null. So my third test scenario is let's create a method named test liquid type with null. Okay, so here I have the assert null method. I'm going to check get liquid type. Since my liquid type is not null, this test is again gonna fail. So my one test failed, one test passed, and one is being ignored. My assert not null. I have water in my cup. So my two tests are passed and one is ignored. Okay. So I think that's all for the introduction to JUnit. Now you have a basic idea of how to generate test cases and how to test the code of Java. Our next video will be covering little advanced concepts of JUnit. If you liked this video, hit on the like button, share with your friends, and subscribe our YouTube channel. Thank you so much for watching us.